All right, this is the last new lesson, isn't it? The last new lesson that we're going to teach this year. Isn't that exciting? No, it's not exciting. We're going to go over some homework and stuff like that. I didn't like the one that you have due today, the law of cosines. I'll collect that tomorrow and the law of sines, and then we'll just spend tomorrow. What do I have for tomorrow? What does it say? Yeah, just work in class on that next assignment. So I'll give you some time to work in class, but we'll also go over some of the homework as well, okay? So I'm pretty sure that's it, isn't it? Yep. And we do have a quiz on Friday. All right? Okay. And then on Thursday, what are you going to do on Thursday? Just review for the quiz? Yeah, so it's piece of cake after today, right? All right, so this is the last thing. And we only got 15 minutes, so let's do this. So the law of sines, I am going to show you what the formula is. There's a little bit of background information I have on my notes. I am not going to show it to you just because of time right now. I'm going to show you what the law of sines is, what it means, and then we're going to do an example. All right, so here it is. Everybody ready? So you could write it two different ways. You could write it, I forgot to change it. Why do I always forget that? Change this thing right here so I can write. There we go. All right, let's try this again. So you could write it like this. Of course, the law of sines, what do you think it's going to have in it? It's going to have a sign in it, right? So it's going to be like this. Now, if you can remember something like this, okay, or, I'll put an or right here, or you could flip it. Now, that's not much of a formula. I agree, because I'm not done. But watch. What we're going to do is just going to repeat this, but we're going to repeat this for angle A inside B, angle C inside C. So it's kind of weird because I have three things equal to each other. And you'll see in the example, we're not actually going to use all three at the same time. We're going to break them up into twos, all right? But I'm going to show you the three. So what do you think? The next one is the same thing except B. So what is that going to be? Right, sine of angle B over side B. Now, what's true about angle A and little a right there? They're opposite each other, exactly. Okay, so this is side A, and this is always the side that's opposite this angle. Everybody understand that? So you got to make sure that that's true. All right, so if you label your triangles ABC, make sure your side A is opposite angle A, and your side B is opposite angle B, and so forth. Everybody got that? All right, so that's the key to remember here. And then what's the third part of this? Sine of angle C over side C. Yep, and that's it. It's pretty easy, isn't it? All right? You're like, okay, it looks easy, but how do you use it? Well, and you could write it like this as well. All right, depending on what you want to solve for. If you wanted to solve for a side, S-I-D-E, if you wanted to solve for a side, which one would you use? Would you use this one or this one? Yeah, this one. Why? Yeah, because it's already on the top, right? You don't want it on the bottom, do you? All right, so you could go either or on this one. All right? All right, and then what's this going to be? B over sine of B and C over sine of C. So that's the law of sines right there. All right? It's not hard to remember, do you think? Nah, it's just, side over the sine of that angle that's opposite that side. And then same thing with all the other ones. So you got to memorize it. Make sure you know it. Let's use it. You ready? So we're going to draw a triangle, and we're going to draw a non-right triangle. This is another method to solve non-right triangles. Because what would you do if you had a right triangle? What would you use? Yeah, sine, cosine, tangent. All right, here's a triangle. Now, there is something that I'm not going to talk about in here. Maybe your Algebra 2 teacher, if you have Mr. Rao. You probably have Mr. Rao, I guess. And there's a situation where this does not work, okay, the law of sines. I'm trying to think of the case. They say it's the ambiguous, that's the word. They call it the ambiguous case. If you want to learn about it, where would you go? Go to YouTube, type in law of sines, ambiguous case, all right? And they'll talk all about that. But the problems that you're going to get in here, it's all going to work, okay? But just so that you know, there are situations where it looks like it can work. It looks like everything's set up like it's going to work, but it doesn't work, all right? And that's called the ambiguous case. We're not going to get into it because we only have the one day. In fact, we only have about 11 minutes left. So we're just going to do ones that work. But I just wanted to throw that out there to you, that there are things that aren't going to work. All right? So, yeah. So let's solve for everything. So if that's side A, what's this going to be? Angle A. If that's side B, this is going to be angle B. And they don't even give you a letter, but you obviously know that's angle C, and this is what? Side C. Okay, everybody good? All right. So could we use the law of cosines on this? We could?
No, we don't know the side.
Yeah, we need another side, don't we? All right, to be able to use the law of cosines, you need two sides. We don't have two sides. Can you use a trig function on this? Can you use regular sine, cosine, and tangent? No, why not? Because it's not a what? Right triangle, okay? Is it a right triangle? I don't know. Maybe it is. We don't know what that angle is. How do you find that angle right there? Yeah, add them up, subtract them from 180, and you'll get 82 degrees. So that's the first thing that I would do, right? Because you want to find, sometimes problems say solve the triangle. Like, what do you mean solve a triangle? It just means what? Find all the missing parts. That's exactly right. So sometimes some books, I don't know if this book says that or not, but some books say solve the triangle. That means just find everything's missing. So that was missing, so we filled it in. That was the easiest thing to do. Agreed? Let me push this over a little bit. Give me some room to write. Okay? All right. So now what we're going to do, we're going to use we're going to use the law of sines. So for the sake of time, let's just solve for A. So what we want to do, we want to take this. Let's drop this down a little bit so I can see it. There we go. What we would do, if I can talk, what we want to do is we want to pair them up, all right? So what are we trying to find? Well, A and B, but pick one. Let's say A, all right? Now, so we're trying to find A. Do we know angle A? Sure we do. It's right here. It's 53. So we know that. Now, we don't want to pick something that we have another unknown, because I only have one unknown, right? And I've already got the unknown, which is A. So what other angle and side am I going to pick? It's angle-side combination. The C, that's right, because I know side C and I know angle C. Everybody with me on that? So if I'm trying to find A, there's 4 parts to it. I have to know 3 of them if I want to find the 4th one. Yes? All right, so I'm going to use that, and I'm going to use this. Does that make sense on which one we use? So I'm going to use the A and the C. So how am I going to write this? A over what? The sine of 53, because that's the angle that's opposite that side A. And then I just said, remember, I'm just using 2 of these. I'm not using all 3. Okay, I'm just grouping them up and picking which 2 I want. So I want this one and I want this one. Okay? So equals C. What's side C? It's 12 over what? Sine of 82. And that's basically it for the law of sines. Basically, we got to do some algebra, all right? But as far as setting it up, that's how you set it up. So do you think that's as easy or easier or harder than the law of cosines? It all depends. Okay, this might be a little easier, to tell you the truth. I think there's a little less calculator work on this than there would be with the law of cosines, but this is pretty good. Now, the reason we put the A on top is because now, how can I get rid of the sine of 53? I just multiply both sides by what? The sine of 53. So I multiply that by the sine of 53, and I come over here and I multiply this by the sine of 53. I'm just going to put it right next to it. That means multiply, doesn't it? Okay, put that little fraction bar. That and that cancel out. Now, if I was doing these problems on a quiz or a test, I don't see any reason why I'd have to write sine of 53 here, then cancel them out. I know it's going to go away. All right? Everybody with me? I harp on showing work all the time, but this is a situation where you don't really need to. You guys are at a point now where you know that multiplying by the sine of 53 cancels each other out. Do you agree? Yeah. So now, what do we got? We got A equals all this. So what do I do with all that? Put it in a calculator. I will give you 30 seconds to come up with an answer. It's going to be approximate. That's good. Did you do it already? Okay. And it does come out to approximately 9.7. So try it though, all right? Again, depends on what kind of calculator you have. If you have a little tiny calculator like this TI-30, all right, this is what I would do. I'm not going to show it to you because I don't have that calculator on the computer, but here's what I would do. I would hit 53 sine first, okay? You understand, on this calculator, you hit the angle, then the function, then the sine. If you have a graphing calculator, just put it in exactly the way it is. Just put 12, and you don't even have to put times, okay? The graphing calculator knows it. So you put 12 sine 53, all right? And then I think you can just put a division, divide, and then sine of 82. You should get 97 or 9.7 if you put it like that. But if you have a little calculator like this, sometimes you got to do the angle first, depending on what calculator you're using. So I would go 53 sine, then I would go times 12, and then hit equals, then divide, and then 82 sine, and then equals again. You follow my steps? You guys need to bring calculators in, all right? Because this is the last time we do this, but you should bring a calculator every single day to this class. It should be in your book bag. You should have it just as much as you have pencils and paper and all that kind of stuff, all right? So give it a shot. Anybody get 9.7? Anybody try it? Okay. Make sure you know how to do that, all right? Then you did it in your head? Sure you did. All right, let's do B. Let's solve for B. And let's bring this down so I can see everything. All right, let's solve for B, this one right here. So I'm going to put B over what? Sine of 45 equals. Now, you could use the A because we found it, but what is A? A is what? It's an approximation. Do I really want to put an approximation in there? No. I mean, technically you can, but your answer may not be as accurate as it should be, okay? So let's go back and use the C again, all right? So I'm going to use 12 over the sine of 82. It's exactly the same steps, just different numbers, all right? Multiply both sides by the sine of 45, okay? That cancels, and then you throw that into your calculator, and approximately it's 8.6, okay? So that's, well, put an A right there, okay? So that's A and that's B, and we found C, piece of cake. Do they have another example? It seems like they should. Maybe I just didn't put it in my notes. Where you have to find an angle, because the math is a little different to find the angle. Let me see. Yeah, they made it kind of weird. Maybe that's why I didn't do that. But tell you what, let's just take that same. I got 3 minutes. Okay, let's take that same problem. Let's pretend. Yeah, let's do this. Let's pretend we didn't know this was 45. Okay? But we did know that this was 9.7. Now, it is an approximation, so we may not get exactly what we're supposed to get, and pretend we didn't know that. Everybody with me on this? Let's get rid of this. Okay, everybody good? I think this will work. Let me see. Yep, I know that. I know that. Let's find angle C. Okay? Let me get rid of all this just so I have some room to write. Okay. So, how would I find angle C? So, yeah. So, on this one, I'm trying to find C. So, which one am I going to use? Remember I said I could use either or? Okay, I'm going to put the angle on top this time. Yeah, it makes it just a little bit easier for me. So watch what I'm going to do. I'm going to go the sine of C over side C. What's side C? 12 equals. Now, what do I know over here? Do I know opposite angle and sides? Yeah, 53 and 9.7. Again, this may not come out exactly to 82 because we're using an approximation here, but it should come out really close, okay? So what are we going to use here? The sine of angle A, which is 53, and over side A, which in this case is 9.7. Now, here's the thing. I got to solve for C. This shouldn't be too hard because we learned how to do this with the law of cosines. What's the first thing you're going to get rid of if you want to get C by itself? The 12. So multiply both sides by 12. So put a 12 right in front of there. And then if I want to get rid of the sign, how do I get rid of the sign? Take the inverse of the sign. So that means that C is equal to the inverse sign of all this. 12 sine of 53 over 9.7. All right? Throw that in your calculator. Let me put it into this calculator. So what I'm going to do, if I have a calculator like this little one, I'm going to do all that stuff in the parentheses first. And then the very last thing, I'm going to hit second function sine. And then I should get my answer. Okay? If you have a graphing calculator, you can put sine, the second function sine first, and then put the other stuff in there. But make sure you know how to use your calculator. All right? So I'm going to hit 53 sine times 12. That equals, divided by 9.7 equals second function sine. And I got 81.1. I told you it wouldn't be exactly 82, right? Why isn't it exactly 82? Because I used a rounded number, right, in there. But they might possibly give you, actual, whole numbers. They don't have to be whole numbers, but they could give you exact numbers, okay? But again, that's why we didn't get 82 degrees. Why did I put 8.1? 81.1 degrees. And that's what you would get with that information. Does that make sense? All right, so that's the hardest part right there for law of sines, is to take that inverse sign. But we've done it already. All right, so do the lesson. It's what, 7 to 12? So, yeah, turn in 1 through 6. And then you'll get 5 points for each of those. Get some extra points. So do 7 to 12, and it's section 12.6b, we'll call it. All right, that's it. Last new lesson of the year.